In this video, we are going to be looking at how to use a heating and cooling curve to answer an energy question that involves more than one step. So the first thing that we need to do is identify the substance that we're looking at. And the substance in our problem is ice. Our question says, how much energy is needed to melt 21.16 grams of ice that was originally at negative 15 degrees Celsius? So let's talk about some things that we know about ice. One of the things that we know about ice is that the melting point of ice is 0 degrees Celsius. So the melting point for this problem, where our substance changes from a solid into a liquid, is going to be 0 degrees Celsius. Now, our problem tells us that we are going to be melting our ice. So we know that in our problem, we are going to be doing this step, going from a solid to a liquid. Our question also tells us that our ice originally began at a temperature of negative 15 degrees Celsius. So that means that our ice did start as a solid, and our solid was at a temperature lower than 0 degrees Celsius. In this case, it was negative 15.6 degrees Celsius. So we know that our ice started somewhere along here on our heating and cooling curve, and it ended when it became a liquid at 0 degrees Celsius. By looking at the number of lines in between the two dots that we've placed on our heating and cooling curve, we can see that our problem is going to involve two steps. One of the steps is going to be involving changing the temperature of our ice from negative 15 degrees Celsius to 0 degrees Celsius. And to change our temperature, we're going to be using the equation Q is equal to mCp delta T. Our second step is going to be involving changing our state of matter from a solid to a liquid in a process called fusion. And the equation that we're going to be using to change state is Q is equal to mH. So let's talk about how we are going to use these two equations to answer the question, how much energy is needed? So our first part of our equation is this step, our changing temperature step. And we're going to call this step Q1. And Q1, we said, was changing our temperature, so we're going to use the equation Q is equal to mCp delta T. So Q, or our heat energy, is what we are trying to find. So this is what we are going to be solving for in our equation. M stands for mass, and our mass in this problem is 21.16 grams. Cp stands for specific heat capacity, and since we are on this part of our graph, we are looking at the specific heat capacity of solid water, or ice, and according to our reference table, the specific heat capacity for ice is 2.05 joules per gram degree Celsius. Delta T means change in temperature, or T final minus T initial. Our initial temperature is negative 15.6 degrees Celsius, and our final temperature, since they say that our ice melts and it doesn't, our problem doesn't tell us that it changes any temperature after that, our final temperature is going to be 0 degrees Celsius minus our initial temperature, which was 15.6 degrees Celsius. So we can plug this information into our equation. Q1 is equal to 21.16 grams times our specific heat capacity, which is 2.05 joules per gram degree Celsius, and our change in temperature, 0 minus negative 15.6 gives us 15.6 degrees Celsius. So if we plug all of this information into our calculator, we would say 21.16 times 2.05 times 15.6. So our answer for Q1 is going to be Q1 is equal to 676.69668, and our unit, gram, cancels out with gram on the bottom, degrees Celsius cancels out with degrees Celsius on the top, to leave us with the unit of joules. Now, we are going to need to use this number a little bit later, so I'm going to store this number on my calculator by hitting the STO button and saving this number as the letter B, so alpha B, and enter, and that gives us our number back. Now, let's do the second part of our equation. The second equation that we're going to use is this change in state equation. So we're going to call this Q2. And our equation for Q2, since we are changing state, is Q is equal to MH. There are lots of different H's that we can use, but since we are going from a solid to a liquid, and the name of that transition is the word fusion, we are going to use HF for heat of fusion. In this problem, Q2, or heat energy, is what we are trying to find, so this is what we are going to be solving for. Our mass in this problem is going to again be 21.16 grams, and our heat of fusion, according to our reference table, is going to be 334 joules per gram. So we can plug this information into our equation. We can say 21.16 grams times 334 joules per gram. If we plug this into our calculator, 21.16 times 334, we get the number 7,067.44 grams on the bottom, cancels out with grams on the top, to leave us with the unit joules. Again, we need this number, so we're going to save it. So we're going to store this number as alpha C so that we can use it. Now, our question is asking us how much energy in total is needed to change a block of ice from negative 15.6 degrees Celsius into melted ice. So the way that we figure that out is by looking for our total heat energy. And our total heat energy is going to be Q1 plus Q2. So Q total is equal to Q1, which we said was 676, plus all of the decimals that came after it, plus our Q2, which we said was 7,067, and all of the decimals that came after that. So our total Q, we can go into our calculator, and since we stored those numbers, we can say our Q1, which we called B, plus our Q2, which we called C. If we press enter, then we get the number 7,744.1368. And since our Q2 was in joules and our Q1 was in joules, our unit here will also be in joules. In our original problem, we had 1, 2, 3, 4 sig figs associated with our mass, and we had 1, 2, 3 sig figs associated with our temperature. So our final answer should have 3 sig figs. So this space. So our final answer is 7,740 joules.